Welcome to the machine age, an introduction to machine learning. Machine learning is transforming our world. It's like teaching computers to learn from experience, without explicit programming. Instead of hard-coded rules, we feed them data, and let them figure out patterns and make predictions. This technology powers a wide range of applications we use every day. Think about personalized recommendations you see on Netflix or Spotify. They are powered by machine learning algorithms that analyze your past behavior and preferences to suggest new content you might enjoy. Similarly, spam filters use machine learning to identify and block unwanted emails, saving you from a cluttered inbox. Fraud detection systems employed by banks and financial institutions leverage machine learning to detect suspicious transactions and prevent financial losses. Self-driving cars, a hot topic in technology, heavily rely on machine learning to navigate their surroundings, interpret sensor data, and make real-time decisions to ensure safe driving. From healthcare to finance, transportation to entertainment, machine learning is revolutionizing industries and shaping the future. But how does it actually work? Let's delve into the step-by-step process of building machine learning models. Defining the challenge is the first step in setting the stage for machine learning success. Before diving into algorithms, we must define the problem we want to solve. This means articulating the question and identifying the type of machine learning task. For example, predicting house prices is a regression problem. Classifying emails as spam or not is a classification problem. We also identify the data we need and the metrics to evaluate success. With a clear problem and data plan, we can move to data preparation. Data is the fuel that powers machine learning. The quality and quantity of data directly impact model accuracy. This stage involves gathering, cleaning, and transforming data for machine learning. For house price prediction, we collect features like address, size, and sales history. Raw data is rarely clean. We handle missing values, outliers, and inconsistencies. Data is split into training and testing sets to ensure reliable model performance. This step is vital for building robust machine learning models. With our data prepared, we need to select a suitable machine learning model for our task. The choice of model depends on the nature of the problem, the type of data we have, and of course the desired outcome. There are numerous machine learning algorithms available, each with its strengths and weaknesses. For our house price prediction example, linear regression is a good starting point. It assumes a linear relationship between the input features, like size and location, and the target variable, which in this case is the price. But, hey, that's just one option. Other algorithms, such as decision trees, random forests, or even deep learning models like neural networks, can be explored to potentially capture more complex relationships in the data. Now, for email classification, we might consider algorithms like naive Bayes, logistic regression, or support vector machines. These algorithms are particularly well suited for classifying text-based data into predefined categories. Selecting the right model often involves a bit of experimentation and comparing the performance of different algorithms to identify the one that yields the best results for our specific problem. Now comes the exciting part. Training the machine learning model. This is where the magic really happens. We feed the prepared training data to the chosen algorithm, allowing it to learn patterns and relationships within the data. The algorithm adjusts its internal parameters iteratively to minimize the difference between its predictions and the actual values in the training data. Let's break this down with our house price example. The model learns from the data, figuring out how features like location, size, and the number of bedrooms influence the price of a house. It picks up on patterns like houses in certain neighborhoods commanding higher prices, or larger houses generally being more expensive. The training process involves feeding the model with data points, making predictions, calculating the error, and then adjusting its internal parameters to reduce that error. This process is repeated over and over again until the model's performance on the training data reaches a satisfactory level. Once the model is trained, we need to evaluate its performance on the unseen testing data. This step is crucial to assess how well the model generalizes to new, unseen data. We use various metrics to measure the model's accuracy, precision, recall, and other relevant performance indicators depending on the nature of the problem. For our house price prediction example, we might use metrics like mean absolute error, or MEI, and root mean squared error, or RMSE, to evaluate how close the model's predictions are to the actual prices in the testing data. A lower error naturally indicates better performance. Similarly, for email classification, we might use metrics like accuracy, the percentage of correctly classified emails, precision, which is the percentage of emails classified as spam that are actually spam, and recall, which is the percentage of actual spam emails correctly identified as spam. Evaluating the model's performance helps us understand its strengths and weaknesses, and importantly, identify areas for improvement. The final step is to deploy the trained machine learning model into a real-world application. This could involve integrating the model into an existing software system, building a web application around it, or deploying it on a cloud platform. For instance, our house price prediction model could be integrated into a real estate website, providing users with estimated property values. Similarly, our spam filter could be deployed on an email server, protecting users from unwanted messages. But deploying a machine learning model isn't the end of the story. It's an iterative process. As new data becomes available, we can retrain and improve the model's performance. We can also monitor its performance over time and make adjustments as needed. The field of machine learning is constantly evolving, with new algorithms and techniques emerging regularly. This iterative process of continuous learning and improvement is key to unlocking the full potential of machine learning and building intelligent systems that can adapt and evolve over time.